This video is going to cover Trig section 1.5 or Pre-Calc section 4.5. The topic for this video is graphing sine and cosine functions. So let's start off by plotting some points to get the graph of the basic sine graph. So if I asked you to graph f of x equals sine of x, really what I'm asking you to graph is just y equals the sine of x. Let's start off with some basic angles here in degree or in radians, and going to our unit circle, let's look at the angle 0 pi. And what is the sine then of 0 pi? Well, the sine of 0 pi from our unit circle is 0. Move up to 90 degrees or pi over 2. What is the sine of pi over 2? Again, from the unit circle, it would be 1. Looking at pi, the sine of pi is 0. Again, I'm looking at the unit circle to get these answers. And then finally, if I move down to 3 pi over 2, the sine of that angle is -1. And going back to 2 pi, where I started, which is the same as 0 pi, it would be 0. So if we plot these, this is what our graph is going to look like. Here's 0, 0. Here is pi over 2, 1. Pi over 2, or pi 0. 3 pi over 2, -1. And this is going up to 1. This is going down to -1 here. And then finally back to 0. The graph is going to be this S-like shaped graph in terms of this smooth curve. It is a curve. It is not pointed. It is a curve. Once we have this graph, what we have just done here is we have graphed one period of the graph. And one period will occur when you get a complete cycle of the graph. So it started here at 0, 0, it went up, it came back down, and then it goes back up again. So this distance here is considered a period. So one cycle of this graph is actually occurring from 0 to 2 pi. So again, some definitions to define here. The period is one cycle of the graph. When we're talking about a cycle for the specific for the sine graph, this is going to be very important information for us down here that I'm going to highlight. The sine graph will start at the origin, so it starts here. It goes back to the top of the amplitude, which we haven't discussed what that is, but I'll show you in just a minute. Goes back down to the origin, or to the x-axis, in this case x-intercept, back down to the bottom of the amplitude and back up. And that's one complete cycle of the graph. The amplitude, which is our next vocabulary term that we need to discuss, the amplitude is when you go up and the distance that you go down here. So this is the distance above or below the graph. So in this case, the distance we went up is 1. The distance that we've gone down is -1, but when we're talking about a distance, we actually aren't going a negative distance. We're going +1 down, which is really, because we're going down, it's negative. So that distance is still is 1. It's going to be very important that you get this basic shape of the graph down. Now we've only done one period. This graph would continue in the same pattern. It would come up, it would go down, it would go back down, it would come up, and it would likewise, it would go this way, it would go down, it would come up, go back down. So this graph is continuous. We just won't be graphing, you know, it continuously. Typically what we will do is we will graph 2 periods. So when we actually start graphing these, we're going to actually graph 2 periods. Spell that right. Now this little guy down here, he's going to be helpful in helping you understand the basic shape of the graph. So again, he starts at the origin, goes up, comes back down through the bottom, and then goes back up to the top of the origin. So you're getting this S-like shape here if you were to highlight his arms, and that's for the sine. Again, remember that the sine starts at the origin. Because now when we look at the cosine graph is going to start differently. So let's look at that next. So if we graph the equation y equals the cosine of x, let's go back to our unit circle, at an angle of 0, what is the cosine? Cosine of 0 is 1. Cosine of pi over 2 is 0. Again, I'm getting this from the unit circle. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. So if we plot these, we go 0, 1, pi over 2, 0, pi negative 1, so here's 1, here's negative 1, 3 pi over 2, 0, and then back up here. So notice what's happening is that the graph is now starting up here, going down, down, up, up. Make that a little bit neater. Down, down, up, up. And again, what's going to be important for us to know here is then that basic shape. So if we're looking at the graph down here, notice that it's starting at the top, goes down and comes back up. It's more of a U. So really just one of his arms is showing you the basic shape. This would be another period of it. Starts at the top, goes down, and comes back up. It's that U-like shape. But it's not considered really a U because this graph is continuous. It keeps going. If we were to repeat the pattern, it would look like that. This side would come down, and it would continue like that. Again, one period here is occurring between 0 and 2 pi again. So if we think about this, since this graph is continuous, what x values are working? Well, since this graph is continuously going this way for all these positive x values and all those negative x values, we would say that all real numbers are working. For the range, the y values that are working, notice that the graph goes up to 1, and down here it goes down to negative 1. So it's not all numbers, it's only those y values that are in between 1 and negative 1. Again, the key concept to understand here is the basic shape of the cosine graph, which I'm highlighting here for you. Cosine starts at the top of the amplitude, and that's different. Cosine starts at the top of the amplitude. So in this case, our amplitude was 1. We went up to 1. We started at the top and we went down to the intercept, down to the bottom of the amplitude, back up to the intercept, and back then up to the top of the amplitude. And that's going to be the pattern. You need to make sure when you're looking at these graphs that you take a look at if it's a cosine or a sine graph and ask yourself, where does it start? Does it start at the origin and go up? Or does it start at the top of the amplitude and go down? And that will depend on whether it's a sine or a cosine graph. So let's take a look at some characteristics of the sine and cosine graphs. There's going to be two generic equations that I've listed for you up here, the sine and then the cosine equation. And you'll notice that what I've done is I've just put A, B's, C's, and D's into these problems, and then A, B, C's, and D's will have certain effects on our graph. A is going to be the amplitude, B is going to help us to figure out what our period is, C and B will help us figure out our phase shift, and D will help us figure out the vertical shift. So these are the formulas that we're going to need to know to be able to find the amplitude, period, phase shift, and vertical shift to be able to graph these. So we're not really going to make a t-table like we made in the last example. What we're going to do is find these characteristics and then graph from there. So my equation here is y equals 3 sine of x. Now what I like to do is write out the generic form above it or below it, doesn't matter, so I can identify what A, B, C, and D are. So the way that this would work is that y is equal to A sine, parenthesis, bx minus c plus d. And then the next thing I'll do is I'll list the formulas off to the side here. The amplitude is given to me up here. It's the absolute value of A. The period is 2 pi divided by B. Phase shift is C divided by B. And the vertical shift is D. So if I find those four things, then I can start to graph it. So to be able to find those things, I need to know what A, B, C, and D are. So looking at this, A, notice that the A is the number that's out in front of the sign, should be 3. B is the number in front of my x term here, so B in this problem is that imaginary 1 that's right here. C is what I'm subtracting from x, and I'm not subtracting anything, so there is no C. So we can either write 0 or none. And then D is what I'm adding to the end of all of this, and really in my parentheses I only have this. I'm not adding anything to the end here, so again that would be 0 or none. So when I do the amplitude, it would be the absolute value of 3, which is 3. That means my graph is going to go up 3 and it's going to go down 3. When I do the period here, the period is going to be 2 pi divided by b. My problem has a b of 1, so my period is going to be 2 pi. That's going to tell me how far over I need to go to stop. My phase shift is going to be, in this case, there is no c, so 0 divided by b is 0. So I have no phase shift. That means phase shift is what my graph moves left or right. So when it's a sine graph, sine starts at the origin unless there's a phase shift. Okay, I don't have a phase shift, so my graph is going to start right here at the origin. And then it'll go up, come down, down, and then back up again. Make that shape, just like the arms are here. My vertical shift tells me how far my graph is moving up or down. So I'll put a U/D for up and down. And in this case, I have no C value, or no D value, so there is no vertical shift. Now the trickiest part about this is coming up with the numbers that go on the number line here. Before, they were given to you on your graph. Now you have to actually calculate them. Here's how you calculate them. To find numbers on x-axis, take the period and divide by 4. So if I take my period here, which is 2 pi, and I divide it by 4, I end up with half pi. Or we would write it as pi over 2. So what I want to do is, starting at 0, I want to move over 1 and put pi over 2 on that. And then I'm going to keep adding pi over 2 to that until I get 4 numbers here, so I have 5 sections. So the next one would be, if I take pi over 2 and I add pi over 2 to that, I get 1 pi. Add pi over 2 to that, I get 3 pi over 2. And add pi over 2 to that, I get 2 pi. So what I have here is my 4 numbers, which gives me 1, 2, 3, 4, 4 sections. I think I said 5 sections a minute ago. I meant to say 4 sections. I really need to have these 4 numbers here in addition to my starting spot so I can get my 5 dots. So I've already got my starting spot here. Now I just continue the pattern. Starts at the origin and would go up to the top of the amplitude, up to 3, back down to here, down to 3, and then back up to 2 pi. And that would be one period. What we need to do is we need to make 2 periods. So if I make 2 periods, what I want to do is continue the pattern but go backwards. So I subtract pi over 2 from everything. So from 0 it would be negative pi over 2. It would be negative pi, negative 3 pi over 2, and negative 2 pi. So once I've done those 4 numbers, I continue my pattern. So now, since I'm going backwards, I go down first, up, up, down. And my graph would look like that. So the starting point, we started at 0, 0. The end point is the end for one period. So I started here, I ended here. This is the coordinate point 0. I'm sorry, the coordinate point 2 pi 0. So if I asked you to, if I changed the problem to just making this be a negative 3 out in the front, the only way that that would change my graph is that normally we did sine started at 0, 0 and went up to the amplitude. Here this means we go down first. Down to bottom of amplitude first. All of the other numbers are going to be the same, but my graph would look like this. Starts here, goes down, comes up, up, and goes back down. So when your A value is negative, that means you go down first. So I'm graphing this on the same axis.